Hey AP students, this is our third review video where we are looking at some general test taking tips for the AP exam. All right, so as a reminder, we're going through units 1 through 7. Those are the topics. Okay, it's not including things like electricity, electrostatics, sound and sound waves, and pipe harmonics. So, I was thinking about how, we're going to miss those things on the AP exam. So I found a comic, a callback to when we were doing circuits. Let's maybe have a moment of silence for our fallen physics topic comrades. Okay. Thank you. Let's jump into what this video is going to talk about. One, we'll talk a little bit about the AP exam. We're not quite going to go through like, first you're going to do this, and then you're going to log in with this, and then you're going to have this e-ticket. We're going to get there. I don't want to give you that info 2 weeks beforehand and then just assume you know it. So for some of the more specifics for actually logging into the College Board interface and all that, we're going to talk about it. We'll make sure it's all cleared up, but we're really going to focus on still how are we going to apply the types of questions that exist from College Board's new test this year to our final exam and just general strategies to do well on those types of questions. Okay, so general AP exam info, some updates. All right, you will be required to pretty much give written explanations, prose, sentences. All right, you are not going to need on the AP exam to create any kind of diagrams. You're not going to have to draw a free body diagram. You're not going to have to draw a graph, and you're not going to have to do math in order to answer a question. So obviously this is a pretty big change, but they're doing that to make sure that people with whatever electronic device they have an easy way of answering. And typing sentences is pretty much the easiest way you can do that. So while you're not going to have to produce those things, which were obviously a big chunk of the AP exams in the past, you may still need to analyze them. Okay, so just because you're not going to make a free body diagram, maybe there's a problem where a student has drawn free body diagrams and you're asked to explain things they get right or get wrong. Same thing about graphs. And I'll show you some examples, both from actual questions we've taken and ones that might appear that are kind of similar. Okay, so just remember that you still might have to analyze them. Now, I do want to mention one thing about the process for the actual College Board interface because it's going to be similar to what we're going to do for my final exam. When it comes to typing, right, when it comes to writing sentences, you can do one of essentially two things. You can type your answer. They're going to have a little like text box. You think of like a Google form, and right, they have a little text box for you to write something. Okay, they'll have it so you could write directly in their text box. Another thing you could do is, and they even recommend this, or they say this is an option on College Board, you could have like 2 windows open on your computer. Obviously, you're not going to have a PDF. You'll have like the College Board website, whatever it is, okay, where the question is. Again, there'll be like a text box over here, but they say you could type your answer in like a Google Doc or a Word doc. So you type everything out, and then you copy and paste. Control-C, you copy everything here, you go back to College Board's website when you're taking the exam, and you just paste your answer. Totally fine. Okay, and therefore you're going to be able to do something similar on my final exam. Now here's the key though. If you're going to go this method, you can't copy and paste in like diagrams. Even though in Microsoft Word and in Google Docs, you can in fact put in JPEGs and things pretty easily, you can't copy that over. Even if it looks like it copied over, College Board is very clear. That little text box will not carry images over it. A grader won't be able to view them. That's okay, because remember, you don't need any diagrams. But if you were thinking of including some picture, you wanted to hand draw something and then paste it in here, you can't do that. So this would be just for text. If you wanted to use an equation, you still could use an equation. They say you can just type it out in the keyboard, and that's pretty funny because you know that I hate keyboard math. But you can see the example. Okay, here I am just with the keyboard, no equation editor. Careful, because sometimes those are JPEGs that get embedded into the document. Just with the keyboard, X for multiply, Maybe use like the little underscore key for subscripts. Okay, look at my example. There's my equation for V equals V naught plus AT. They'll accept it. They will suffer through those graders to read it. So you could do an equation this way, but just type it out with the keyboard. Again, careful using equation editors on Google Docs or on Microsoft Word, because sometimes that's embedded as like a picture, and you can't copy and paste anything other than text, okay? The other option is you can upload a file, and there's kind of two categories for that. One, you could write everything by hand on a piece of paper. Then you could take a picture of it and upload that as a JPEG, okay? Now, if you do that, that's fine, but they're very clear and saying you gotta be careful. You gotta make sure you have very clear handwriting. Make sure you have dark ink or dark pencil on light paper. Because if they can't read what you took an image of, obviously you're not gonna get any points, okay? They said these are 3 acceptable photo formats. And this is normally the format you use if you like take a picture and then email it to yourself. It's usually gonna be one of these things anyway, okay? Now, you could, let's say you were typing things out in a Google Doc, and then you wanted to like save that as a doc or a text file or a PDF. You could do that and upload it. So this is almost like a kind of an in-between. You could type it out in a Word document and then save that file and then upload that file. That's totally fine, but they again give the warning. Don't include any diagrams in here. They're either not going to look at them or they fear it might not, translate in whatever program they're using. These aren't my rules. This is what's coming from College Board, okay? So if you're like, oh, well, I can include a diagram and then I can like save it as a PDF, you got to be careful. They're saying if you're submitting a doc including PDF, there shouldn't be any diagrams, just text. Okay, if I get updated info, or if one of you hears some updated info, let me know, and we'll adjust this information as needed. Okay, for Mr. Thrasher's final exam, it is next Wednesday. It is May 6th at 1 p.m. Right about 1 p.m., I'm going to unlock the final exam on Canvas. Now, Canvas has quizzes, so it's going to say final exam, and it might say quiz on there. Okay, now we're going to be submitting with Canvas, and I'm going to try to, as best I can, match what you need to do for the AP test. And that works well for some things, not so well for other things. Okay, first, on Canvas, your final exam, you can only see one question at a time. You're going to see question 1, the qualitative, quantitative. You're going to write out your answers. You're going to submit, and then you're going to move on to question 2. Once you move on to question 2, I have set up the final. I have set up this quiz to not allow you to go back. And that's similar to the AP exam. Okay, you can only see the first question. You got those 25 minutes. You submit it, and then you move on to the second question. I am gonna time the quiz, okay? But here's something I cannot do on Canvas. I can't assign time for each specific question. So on College Board for the AP exam, you should know that you get 25 minutes for question 1 and 5 minutes to upload. I can't do that on Canvas unless I had 2 separate quizzes, and that seems more like a hassle, okay? So while I'm gonna give you the overall time, so 25 minutes plus 5 minutes, plus the 15 minutes for question 2 plus 5 minutes, I'll give you that total time, but it's not going to be per question. That might be a help to you, but you should keep an eye on the clock, okay? Also, for the exam, Canvas does not allow me the option of either a text box or a file upload, which College Board will allow. On the actual AP exam, as I just said, you can either copy and paste into a little text box for their College Board website, or you can upload a document, a doc, a JPEG, etc. I can't do that in Canvas. So because of that, I just have to pick one of them. So what I've chosen is the file upload. You could either upload a picture, and that could be a picture of your writing and stuff, or it could be like a Google Doc file, or a Word document file, or a PDF file. I apologize, I wish I could have the 2 options like College Board is going to let you do, but Canvas doesn't let me. Okay, so it is going to be a little bit different, both in terms of time, and I always am going to have some kind of file upload. But it could just be text, and then you link that Google Doc or you upload the Word doc, or it could be a JPEG. So you still have that kind of option. Okay, now the final exam is 10% of your grade, but let me be crystal clear. Okay, the goal of this final exam is not to fail anybody. Okay, the goal is to mimic the AP exam. So I recognize you could probably find whatever question I give you online. I get it. That's not the point. The point is to try this process where you see one question at a time. Okay, you gotta submit, then you see the second question. You gotta upload images, copying and pasting, all that. You got this time limit. I know I have to tweak that a little bit. Okay, the goal is to practice. Here is my promise to you, right here, right now. Play this in front of Ms. Shu if you think I'm going against it. If you're passing, if you're earning credit right now, by the time we take the final exam, I promise you, if the final exam with this 10% happens, which I don't think is likely, but if it happens to make you all of a sudden not pass, I promise I'll give you the opportunity to do a form of test corrections where you can raise that grade above to earn credit. Okay, I promise you, this final exam will not make you earn no credit. Most of you are easily going to sail and get credit anyway. All right, so please don't be cheating. It doesn't serve any purpose. Okay, I don't care if you blow these problems. We're still practicing. Okay, but if this ends up making you go from credit to not credit, I promise you the opportunity to earn back some points so you do in fact pass. Now, if you are currently failing, if you've been failing this whole semester, well, this final exam I'm not saying is suddenly going to make you pass. Okay, it has a maximum of 10% of your grade. Okay, but again, if this makes you fail, makes you earn no credit, you'll have the opportunity to get back over that line. If you have questions, feel free to email me. Okay, so I already said this. You're going to see one question at a time, but you have to upload things. Okay, so overall the quiz will be 60 minutes or so. I'll double check the time. But like I said, the individual thing isn't timed. Yeah, I already said both of these things. Okay, let's look at some general test tips. Analyzing equations. Remember, you're not going to have to write an equation, but maybe you're going to need to analyze an equation. If you need to analyze equations, what are some tips? And here's free response practice 2, one of those problems. First, if you read a question and it says there's a constant, hopefully this problem seems familiar and I don't have to explain the whole thing again. If it says there's a constant, you can almost certainly kind of ignore it. They include constants to make sure things make physics sense. But the question, I've never seen a question where it was the constant that affected the answer. It's just there to make sure the question works or the equation works. Like right here, I have torque, and the only other variable is time. Torque does not equal time, right? Those are two different things. But you gotta make sure that your physics equation is valid. So, I mean, obviously read the problem. If it makes it seem like this constant is some important role, maybe this isn't gonna apply. But for the most part, if you see a constant, don't worry about it. You're looking for this problem at how torque relates to time. That's the problem for this question, okay? Also, spend time thinking, what is the equation telling me? It's easy to get overwhelmed, right? You look at this whole thing, you're like, oh my God, this is a nightmare. Thrasher never showed me this. That guy screwed me over. To be honest, College Board likes to give equations that are not part of the curriculum, but it's a question asking, can you analyze an equation? Not, do you know that specific equation? And that applies here, right? You look at this equation like, oh my gosh, I don't know what this is, but spend a little time thinking. Okay, I have torque. So this equation is saying torque is related to a constant, but I'm going to ignore that, and t, and time. They're like subtracting, and that's maybe annoying, and that might be tough, and you might have to spend more time figuring out what this is, but at the basic level, this is an equation that says torque is related to time. All right? And then for a lot of these problems, you're looking at the relationship in terms of, are things in the numerator or the denominator? Sometimes it'll have to do with exponents, but that's pretty rare. Almost all these analysis questions is, does it make sense that something's in the numerator? Does it make sense that something's in the denominator? And that's exactly what this question was asking. Okay, here, because you have all the times just kind of all being multiplied, right? C is being multiplied by all this stuff, it's all on the top. If t gets big, torque gets big. So really, in English, what this equation is showing is more time, more torque. And then the physics of it is, does that match the scenario? Whereas look at this equation. Here I have time in the denominator. So if I make the denominator big, that makes the result small. This equation is saying when time gets big, the torque gets small. Does that match the scenario? Okay, so a lot of these is, does an equation match a scenario? The very last one, it's maybe a little ironic that it's at the very bottom of my, my list of things to think about, is does it make physics sense? Again, some equations, they might be things you've never seen before. And you might have to be like, well, in general, does it make sense that torque is related to time, for one example? Okay, sometimes that might be hard to do, and sometimes you might not have to do this at all. You don't really need to do this for this problem. This is all about, does this match the scenario? But, you know, we know Newton's second law. We know rules of energy conservation. We should know things like if speed increases, the kinetic energy should increase. So if you have an equation where you have kinetic energy is equal to something with speed on the bottom, well, maybe if you get to this bullet point, you start thinking, well, wait a minute, speed is increasing kinetic energy, so why would it be in the denominator? Okay, let's look at another application. So another question, and again, we already saw this question. Here they gave you an equation, you weren't deriving, so again, this could be a good question that they might ask on the actual test. Let's go through our bullet points here. First, we can ignore constants. Well, there's no constants in this equation. Second bullet point, spend time thinking, what is the equation telling me? Okay, if you don't remember this problem, this was that rod and a student is like throwing a disc at it and then it's sticking together and then rotating. Okay, so let's think. It says omega, that was the speed of that rod. It's related to the inertia of the rod. Okay, makes sense. X, how far away that disc is hitting the rod. V naught, oh, that was the initial speed of the rod. I would go through it. You're maybe not going to learn the answer to the problem doing this second bullet point, but spend time. What is this equation saying? Okay, it's related to a whole bunch of things. I, X, V naught, the mass of the disc, D. Okay, so there's a lot going on in this equation. And then, oh, I just realized I spelled denominator wrong. Oh well. Look at the numerator or the denominator. The denominator. How does it affect? And that's key in this problem. This is saying here that when the rotational inertia of the disk is big, the rotational speed of the disk is big. Does that maybe match a scenario? Or for this problem, does that make physics sense? Does it make sense that if this rod has more inertia, it's going to be moving faster? Well, probably not, right? Newton's second law. If you have more mass, more inertia, well, for a given force, the acceleration is going to be less. Your change in speed would be less. Okay, but try and go through these. One, ignore constants if you see them, unless the problem is really nudging you to focus on those constants. All right, but think about what the equation is giving you. Go through it. All right, and then think about that numerator and denominator. Okay, analyzing graphs. Okay, so analyzing graphs. These are my last couple slides. I know this is a long video, but this is general test-taking tips. Okay, I know I have a multiple choice, and you're not having multiple choice on the test, but analyzing graphs, they might give you a graph like this multiple choice question, and you have to analyze it. So what are my tips for that? Carefully read the axes. Make sure you know what the axes are telling you. So maybe before you even like try and answer the problem, right? You read the scenario, you look at the graphic, okay, the x-axis. The x-axis is time. Okay, obviously more time is going on as we're moving to the right. On the y-axis, ooh, this was a tough question. This was not a graph of momentum. It wasn't even a graph of change in momentum. It was rate of change of linear momentum. This, whenever you see the term rate of, that means like with respect to time. So if you see like the rate of displacement, that's displacement over time. That's what rate means. They're talking about rate in terms of time. So I have the change in momentum divided by time. This was a weird graph. Not all of them would be this complicated, but analyze those y-axes. Make sure you know what it's saying. That's worth the 1 to 2 minutes to make sure you know what it's saying. Second bullet point, think, does the graph correspond to an entire system one object or multiple objects. A lot of times, especially if your scenario is interacting things, that's going to be crucial. And most people get this problem wrong. And I saw your multiple choices. You got this problem wrong because people think this is a graph of both of these objects. And that is not true. Read this carefully. Rate of change of linear momentum of the sphere of mass m. Okay, or think of that spring problem for free response practice 2. Maybe they give you a graph, but it's a graph for the kinetic energy of just the bottom block. You got to be careful because obviously that's going to change your analysis. If it's just one object, like one object flying through the air, well, the graph is probably just going to be that one object, but make sure you know what the graph is referring to. And then we've done this a ton of times. Think about meaningful things. We've learned about area under the curve. Whether it's a graph you've seen before, for force versus displacement, or maybe it's a graph you've never seen before, they might give that to you. Don't curse my name. You're going to do the same analysis that we've done. Okay, Thrasher, he screwed me over. I've never seen this graph before, but let's see if the area under the curve tells me something. Think about those units. Think about the slope. Okay, I've never seen this graph, but what would the slope be? The other thing, and we admittedly have not focused on this as much, intersections. Okay, what do the intersections represent? And it's really helpful to spend your time on that. And let's look at that mostly with this second example, or I'm actually going to have a third example in just a moment. Okay, for one of our free response questions, you had to draw the graphs, but imagine they gave you the graphs and they asked, like, a student makes this graph, do you agree with what they drew? That's very likely, very possible on the AP exam. And that's where you might need to do this. So I know we're not making graphs, but you might still have to analyze them. Okay, my last real thing. Here was another multiple choice where you had this vertical rotating disk. There was a mass that was hanging off it. This applied a torque. So where you see applied torque, that's this, when you're hanging a mass. And it was asking if there's friction, which of these graphs best matches the omega divided by t versus time of this disk. So let's go through it. Let's carefully read the axes. Okay, I have applied torque on the x-axis. Oh my gosh, Thrasher, you've never shown us a graph with applied torque. You screwed us over. What's the y-axis? Omega divided by t. That's kind of weird. But that seems kind of like acceleration, right? Acceleration is the change in velocity divided by time. This doesn't look exactly like this, but this seems at the very least similar to acceleration. It does in fact equal acceleration, but maybe you don't get that. But it's similar to acceleration. So as acceleration increases, that's me going up, and as torque increases, going to the right. Okay. Now, this was a graph of just the disk. It's not this hanging mass, so it's just the disk. So now I understand what it's applying to. And what might be meaningful? The area under the curve? It turns out that doesn't help you for this problem. Omega f divided by t multiplied by torque? Ugh, yuck, I don't know what that would be. The slope? Oh, that seems yucky as well. That ends up not helping you either. But the intersections are very meaningful. And here's what I mean. Let's look at scenario D. D is saying, reading that x-axis, the torque when it's 0, right? When the x-axis, when the applied torque is 0, meaning there's nothing hanging off of it. When there's no applied torque, this object already has a big acceleration or something similar. Does that make sense? If I have a disk, I'm not applying a torque. Does it make sense that that disk has a big acceleration? No. And this is saying as torque gets bigger, that acceleration is getting smaller. As I add more and more torque, do you expect this acceleration to go down? Probably not, right? So D doesn't make any sense based on looking at the intersection. Same thing with B. B is saying that I have 0 torque and maybe a little acceleration, or maybe maybe it's close to 0. So maybe it's okay, but even this one's getting a little tricky. Whereas look at option A. Notice it's hitting the x-axis right here. What is that saying? It's saying I start accelerating when I have not this amount of torque, not this amount of torque, but when I have this amount of torque. And this is a tough problem. But does it make sense that I start accelerating? First, I have zero acceleration, zero acceleration, zero acceleration, zero acceleration. Now I have acceleration after I hit some amount of torque. That does work in this problem because this is a problem that's all about friction. Think of static friction. I push on my table. At first, it's not moving. I apply more force, still not moving. I apply more force, still not moving. I need to apply a certain amount of force to get something to accelerate. And that's why A was the best answer for this problem. Okay, this intersection really is important. Again, you're obviously not going to get multiple choice in the free response, but maybe they ask, like, one student draws this graph, one student draws this graph. Which do you agree with? And use this kind of analysis to help you out. Okay, I know this was a long video. Maybe you do it over a couple days or so. Of course, I'm saying this at the end. But thanks for watching.